Hello everyone, I'm Miguel Amado, I'm a developer advocate for OutSystems, and today I'm going to be talking about SQL queries. Dashboards are very important for your customer applications or your own applications. Everyone wants to see the data very clear, and we're going to see how we can feed the dashboard with a lot of data. I assume that you already know what joins are, what to do selects, to do insert intos, and we're going to go a little bit deeper and talk about window functions, how to do subqueries, how to optimize. It's going to be fun. So come with me. Warning. This video may contain reference to songs, at least 8 of them. Music is my radar, and when I'm concentrating, my brain drifts to some lyrics. So see if you can find them and leave it in the comments. The story I'm using to show you these queries is that my family has a car renting business. It's not real, but I wish we maybe would be rich. But it's a car renting business, and we call it Amado's Car Renting. We have an application in OutSystems, and we have a database in PostgreSQL from AWS, an Aurora database, and we are going to use the data from the Aurora in the OutSystems application. We are going to be using pgadmin 4 to do some queries and get some data and show you the final result. So let's see what that is all about. We have here our dashboard with the essential information to manage our business. We're going to start with the 3 main cards, the active branch, the active customers, and the car renting contracts for this year. A comparison between last year and this year, monthly rentals. An unpopular fleet where you see the least used cars per branch and see if you have to replace them. And we have the top branches, our biggest query, where we get the total rentals for this year. We have the tendency from comparing last year to last month to this month, and we have the top used car for each branch. Finally, the longest contracts and the top customers, fairly simple queries that we will also be checking. And these are our assumptions for today. So let's go and do some queries. To understand how our data model works, we are going to use the Odyssey Studio. This is where our application was built. And we have an external database that is being hosted in AWS, an Aurora Postgres SQL database that is called Car Rental. I already did the connections, and the very cool feature here is that I can select all the entities that we have here and drag them here. And I can see a full schematics and the relations between our data, our entities. So we have here a vehicle entity. This represents our cars, each car from our fleet. We have our branches. Here it's our stores. We have customers, very straightforward. And finally, we have our rental entity. This is where we store our contracts. This represents a contract for a rental, and they have a vehicle, they have a customer, and they have a branch. So let's begin. Let's go to our IDE, pgadmin 4. I already established a connection to the car renting place, to the car renting database on AWS Aurora. We have here our tables. Apparently we have one extra table, a random VIN, probably from some scripts that I created to populate the database. My bad, this shouldn't be here. It was an honest mistake. So let's go here and start querying. Looking into our dashboards, we want to get the active branches. This means any branch that had a rental during this year, the current year, that is 2025. Then we have the active customers, the same thing, customers from the rentals from this year. And finally, the number of rentals we had so far this year. So, going back, we can start by doing a select, and let's count how many rentals do we have. So I'm going to count, select count from rental. This should be straightforward. I'm going to do a where clause, and I'm going to use the function extract. This extract function serves for you to remove a part of your timestamp or of your date. You can remove the day, the month, the year, or anything else. So I'm going to extract a year from, I have my rental, and I'm going to put the start date. Let's go through now with the active branches. I'm going to start to structure a little bit this query, and please bear with me. I'm too messy. It's just sometimes I capitalize letters, the other times I don't. I'm trying to indent a little bit, but in terms, bear with my mess. So the branch ID is the identifier of branches, and I want to count how many branches I have. This is giving me the same number, and kind of makes sense because we're just counting how many branches ID there. We're not distinguishing them. So we need to count a distinct branch ID. So if we go ahead, we already have only 197 branches. A cool thing about distinct is that you can use distinct or you can use distinct on. So if we do this and we do an F5, we can see that we have a lot of vehicles. If we do this, we can see that we have 170 different make model pairs. So if we look at, for example, at Audi is being, although we use distinct, Audi is being listed twice because we are making a distinct with a make and the model. If we do a distinct on, we can do some really cool stuff. That is, if I make here make, if I put here make and I do this, now we'll see only 46 rows, and you don't have repeated makes because now you're doing a distinct on the make only. So when the make is repeated and the model is different, the query is only returning the first one that it found. We already have the active branches, the car renting contracts. Now we just need the customers. Just put a distinct, and here we put the customer ID as total customers, and running this query, we are going to get 13,505. This covers our cars. It was pretty easy. We just saw a little bit of distinct here, a count there, and we were done. Now let's go to our chart. We can see here that we have a distribution per month of our number of rentals throughout 2024 and 2025 so far. We're counting rentals, right? So let's select count from rental. So far, so good. Let's start structuring this. We need to show the month for each for the rentals, and we're going to select to extract first the year from the date. So we are showing now the number of rentals, the year, the month, but we need to group this information, right? So we're going to select this, and we're going to put here a group by selecting all of this. We get whoopsie, made a whoopsie. Where's it's the comma chameleon. There you go. So this is very weirdly distributed. Let's put an order by series year, ordered by series month. Let's put the count here, and we put a where clause. This is in 2024, 2025. 74, 75, no, 24, 25, yeah, there you go. So, and we can see here in our results that we have the series months, the January, February, March, and we have here the counts for each value. Wonderful. Now, this is working. This could be our thing. But there's one problem. Imagine that I have a month that all of the branches were closed, for example. This means that if we do this query, there's going to be missing here a month. One way to avoid this is first query and get the months that we are working with, and then join that with our result. And for that, we're going to use a common table expression. These are expressions that you can do a query, store this information, and then query that result. This is very cool and it's very useful. So let's go ahead, just here give it some space, and let's play with it. And we do this. If we select this and run it, we can see here the timestamps, and we have 1st of January, 1st of February, 1st of March from 2024 until 2025. So this gives us all the months that we want to get data and information about. Now, we have here our generated series. So we are going to do a CTE. And for that, I'm going to use the keyword with. So with months as this thing, this means that this little keyword is going to turn this result that we have here into a queryable table. Let's call it's not a table, but let's call it. So now I can do queries to this. So we jump ahead to the end of the query. I had to fix some syntax errors, but now we are selecting the year, the name of the month, the January, February, and so on, and the total rentals for each one of those months. We are using coalesce, that is a function that returns the first non-null value of an expression, or if it doesn't find the number, it selects a 0. It's a cool function to make sure you don't have nulls. And since we are left joining with the CTE of the months, that means that we are only going to get in the result the data for these months, the interval that we generated with the generated series. For the unpopular fleet, we're going to need to go to an entity that is called branch vehicle that shows what vehicles are currently in the parking lots of each branch. And we need to check the rentals to see if they have been rented or not. Now, we can go, like every query, we can have a different approach. What we're going to start to do is first calculate for each branch the total of vehicles, then calculate the number of vehicles that are not being used, finally doing some math and getting the percentage. We are using the branch ID. We are using once again coalesce, so we make sure there's no null value and there's a 0. And we are querying the branch total, and we are joining with the unrented vehicles as UV. We are joining everything by branch ID. So we have here the total vehicles that come from the branch total, and then we are doing a round function to round the result, and we are multiplying by 100. We are using an if to make sure there are no problems with nulls, and we are calculating the percentage. So let's run everything, and we have here the percentages. So the highest percentage of unrented vehicles, so the problematic branches that we need to take care of. Looking to our application, we're going to go to the top branches. So we have the total number of rentals for each branch this year. We have the tendency, so the number of sales this month versus the last month. And we have finally the top vehicle. So let's handle each of these problems one by one. Okay, so first let's go to the monthly rentals. We are going to do a CTE, so with first let's do a select. We want to put the date field. We're extract here from start date, so from the rental start date is the same as I'm going to put here by a group by branch ID. Put here the branch ID. We are going to need the date for each month. So this way we can calculate the rentals per month. We don't care about the day. Now we want the total rent. We want to know what we have, how many rents we have this, how many rentals we have this year. We want to know how many rentals we have this month, and we want to know how many rentals we had last month. So for this, we're going to use a very cool window function. It is going to be lag. So what does this mean? Partitioning by branch ID. So this is going to do lag for each branch ID. I'm going to lag the count, and I'm going to separate it order by the date. So since it's separated by month, this means that imagine I sell 10 cars this month, I rent 10 cars this month, and the previous month I rent 5. What's going to appear here on this column, it's going to, for this month, is going to be 5. And we'll see that in a bit. Let's group by rental month. So let's run, and there you go. We have for each branch. So so far we are in March. So for January, since we don't have any previous data or in this query, we have in the database, but don't have in this query, it's going to be null. And we have the total rentals. Then we have for February, we have 37 on the total rentals, and we have here the value for the for the total rentals of last month, and then onwards and so forth. Cool. So in here we have our monthly rentals. Let's move on and see our top vehicle. First things first. Let's select the branch ID. We have here the make, concatenated with a space, then the model, space, then the model year. So we are considering this one vehicle. We want to know the count also. And we're going to use here a second window function that is called row number. I want to know the top vehicle for each branch. So I'm going to order my query to see each vehicle, how many times they were rented, and then I want to order that and only take the top one. So I'm going to say row number, and besides row number, you could also use rank or dense rank. They are similar functions, but in this case, the rank two vehicles can be the number one. And for our case, we don't care if two vehicles are the number one, we just want one of them. So we are using row number and always selecting the first row. Row number, this is over a partition. So I'm partitioning by the branch ID, as I said, and I'm ordering by the count from the highest to the lowest. This way, I will always have the highest. We need to do inner join. Want to put here, extract the year of the date and make sure we are only getting information from this year. Finally, we are going to group by the branch and the top vehicle. So if we run this, we have this result. We have here a problem because we are showing all the row numbers. So as I was saying, for branch 1, we have here the Hyundai. It was rented 5 times, and the row number is 1. Rivian is 3 times, it's 2, and for onwards. So if instead of row number we use rank, if we do the same query, you can see that we have the Hyundai and it's ranking 1, but then all the other ones, since they have the same value, they are the same number. And by the way, we can check the difference between rank and dense rank. We can see here that from number 2 it jumps to number 6. If we go here, dense rank, and we do this, there you go. It's 1 and then 2, 2, 2, 2, 2, but then it jumps to 3 instead of 6. So for your case, you can have a different flavor of these window functions. In our case, we are going to go here and go to row number. This select becomes a subquery. So we have branch ID, we have top vehicle, and then we have rental count. We can say that where's the rank? We can say that my rank is equal to 1. So we are saying just the top line of the row number. This second bigger query now becomes this. So for each branch, just one car selected, the top one. I know this is very confusing. I'm the problem, it's me. It could be a little bit more better indented, but bear with me, it's a big query, but it's going to work. I'm going to get the branch ID, the branch name. Remember the previous query from the monthly rentals? If we have each total for each month, we can sum all the totals and have the total for that branch. So we're doing a sum, but we're doing here a case clause. What we are doing here is, in case is this month, use the previous month rentals, else count as 0. What is this is going to do? This is going to sum 0 plus the previous month's rental. We have here the same, but for this month's rental. So the month is March, it's the value of the total rentals, and it's going to be stored in this column. This takes care of the sum. Now we want the most used car, so we need to do here a join. Here we go. We are going to left join the branch. We are going to left join the branch so we can have here the branch name, group by the branch ID, the name, and the most used car, and order by branch ID. There you go. So we have Bellevue, total per branch, previous month's rentals, this month's rentals, and most used car. Now, that was a lot of SQL querying. We're still missing the longest contracts and the top customers. But to change it a little bit, instead of doing in pgadmin 4, I want to do these queries on the OutSystems side and show you how it all connects on this dashboard. So before going into it, I want to talk about the new feature for OutSystems that we are going to use. It's very exciting. It's called SQL for external entities. It sits on top of our data fabric, and I absolutely love it. But for the absolute beginners, let me tell you what data fabric is. So if you have an SAP, a Salesforce connection, and a PostgreSQL database, and you want to see all the data combined in one place, Data Fabric from OutSystems, it's the answer to that. We use something called aggregates to see all that data in only one place. So you can get your customers from Salesforce and then your orders from SAP and see it all in only one query without having to know how does the querying in one works and in the other works. Now, this SQL for external entities, it's a brand new feature that sits on top of ANSI 92 with a little bit of more muscle in it and allows you to, using only one language, do advanced queries, so do queries that you want, so do selects, widths, and all that stuff, but to all those external entities. So everything is only done with one language. It's very cool, and let's see how we can use it. This is Odyssey Studio. where we develop our application. I'm currently showing you the dashboard where we have all our queries. We have here the data actions where we fetch the information. We're going to first take a look into the chart. So I wanted to redo the chart query, but using aggregates to show you the power of them. I'm going to create an aggregate and add this rental entity to it. Then we just want rentals from last year or this year, so I'm going to put here higher than 2024. Then I'm going to create an extended attribute, so I'm going to work on the start date and create a column for the year and for the month. Now we just need to group by this year and this month and do a count. Then do a sort, and we have all the information in this aggregate. Remember that we're accessing a external database, so if we were be external SAP or something, it would be this kind of language. We don't need to know syntax and anything like that. That's really cool. Now let's see something a little more fun. Let's go to our longest contracts query. So I'm in the data action. I'm going to drag here an advanced query, and I'm going to start to do some SQL. So I have here select, I'm selecting from the rentals, I'm doing inner join. For the output, don't forget I'm using a test structure, so I can just test out and then change for the real one. You can see that it's just normal SQL. To calculate the time difference from the start date and the end date, I'm using a timestamp diff, and I'm doing an average of it. That's the syntax that may vary a little, but it's just normal SQL. So we're extracting the date to see the year that we're doing this, group by, and we are putting a limit. So we can test the SQL, and I just need to fix here, and voila, we have results. For the top customer, we're going to do basically the same. Go to the data action, go to the SQL node, do your query. It's going to be very similar. We are calculating the number of days that each customer had rentals and then ordering it. We're going to use the timestamp diff, but the difference is that instead of the average, we want the sum. We want to check out the customer information, group by customer, and we have our query. There you go. This is the end. There was a lot of querying. I hope that you learned something or at least had some fun with it. Check our channel and subscribe. We have a lot of similar videos with a lot of technologies. By the way, did you find the songs that I referenced? If you did, leave us in the comments. And yeah, that's it. Thank you for watching.